All right, quantum numbers. First, this is like a review of just what they can be. This is the possible values. Principal quantum number n, it can have values. It's simply going to be the energy level. So like n is going to be equal to 1, 2, 3, 4, 5. On our periodic table, they stop at 7 periods. All right. Angular momentum, L, can have integer values from 0 to n minus 1. That's the possible values. Now, the magnetic quantum number represented m, lowercase little l, I usually just call it m, that can be negative L to positive L. And you have to make sure you include 0 in the middle there in that. So like if it's 1, okay, then it could be, possible values would be negative 1, 0, or 1. All right, so we're just going to kind of, all this sheet really is doing is basically making you practice and get comfortable with the different values of quantum numbers. That's the major goal here. All right, so when n is equal to 3, L can have values of, well, this is all really basic math basically. Just you say n is equal to 3. Our possible values of L are 0 to n minus 1, so it's going to be 0. N is equal to 3, so what's n minus 1? 2, so you can go 1, 2. All right? Now, this next part you actually have to think about a little bit, okay? Do you remember what we said? We kind of gave assignments to the orbitals in regard to L. So we said if L is equal to, and really it's right here. So if L is equal to 0, it's S. If L is equal to 1, it's P. If L is equal to 2, it is D. And finally, 3 is F. All right? That is going to be kind of one of those things you just kind of want to remember. I don't have any fancy tricks or anything else to connect that to. You're going to have to remember that. Okay? Which does make sense if you think S, P, D, and F, you know, it goes from biggest or smallest to biggest. So 3D, what's the value of L then? 2. I mean, that's it. All right. When n is equal to 4, L can have values of 0, 1, 2, 3. I'm just kind of going to go through this a little bit. If you get confused, please just tell me to stop. 4P, well, L, we just said P is going to have L be 1. N is equal to 2. L can have values are 1 or 2. 2s, it's going to mean L is 0. Because remember, 0 counts. 0 is something in this quantum number stuff. Normally 0 is nothing. Here it is something. Pardon? Because you have S. So anytime you have an S orbital, okay, or an S sublevel, anytime, that is going to be 0 for L. Because the 0 corresponds to the L. Okay? Now this one seemed to confuse a lot of people. 4. Someone tried to ask me the question while I was playing basketball yesterday about this. And I tried to answer, but I was out of breath, so I don't know if I told them right. So N, L, and M. First, 4D. This is an easy question, but a lot of you get it messed up. What is the energy level for 4D? 4, which means this is asking us for the quantum numbers for each orbital, for every orbital in this one. So what are they all? What energy level are they all in? 4. So you write 4 for all of them. Because you're going to notice the quantum numbers for a lot of these are very similar, actually. All right, L. What did we just say? L is when you have a D sublevel. 2. So 1, so just keep writing 2. They're the same. Because, and in truth they should be, because this is like saying, you know, all of these orbitals live in the same house, basically. Maybe just different rooms now. Okay? But, I mean, the street address would be the same, right? Because they're all the same place. Then finally, ML, you just simply refer back to the fact that possible values are negative L to positive L, so it's going to be negative 2, negative 1, 0, 1, 2. Does that make sense? Any questions at all? Yes?
Wouldn't it be like negative 2 to 2?
What do you mean?
The first one would be negative 2, negative 1, 2.
For like this little box? No, because this is asking for, she's asking wouldn't the negative 2 to positive 2 be included in every box? And no, because this wants us to write the quantum numbers for the 5 orbitals in this d sublevel. Now, if you were to somehow include 5 of those in each box, that'd be like saying you have 25 orbitals in that d sublevel, which is not the case. Each one of these, -1, -2, -1, represents a dash that you would write out like when you're writing out 4D. Each one of those represents 1, so you couldn't have all 5 in a box. Okay. All right. 5. Rank the. Oh, by the way, if you ever see a reference to the book on something, that's obviously for a book we don't have. That's from a totally different class, by the way. This is actually a worksheet I gave to my AP kids a couple years ago. So, good job, by the way. Yeah, you are very smart. So, energy levels. Let's see. This is straight off of what we did before. It just goes 1s, 2s, 2p, 3s, 3p, 4s, 3d. Is that it?
Yeah.
Okay. That one I hope you didn't have problems with, because that's stuff I expect you to know by now. All right, how many orbitals in an atom can have the following quantum number or designation? Okay, here's what this is asking. How many orbitals? Okay? So it's saying basically how specific stuff is. The first couple are easy. How many orbitals are just in a simple p sublevel?
3.
3. You got to remember that. How many in the p sublevel again? 3. This one, though, is a little bit different. 4px. This is representing, remember how we said the p sublevel has 3 orbitals and each one of those is shaped like a dumbbell and they're on the x, the y, and the z axis? If you remember that, then you remember that this is indicating one of those orbitals specifically, the p orbital on the x-axis. So it's just 1. Does that bring up questions? Because I know this is one that a lot of people had confusion on and questions on. All right.
Yeah, where'd the X come from?
The x is okay. So the x is indicating, like imagine you have a 3-dimensional graph where you've got the x, the y, and the z axis. The z being the one that comes out towards you. There are 3 p orbitals on there. Okay, each one oriented with an axis. This one is telling you specifically it's the p orbital on the x-axis. So it's indicating specifically which, like if you had 3 dashes for p, it's indicating which dash it is basically. Okay, it's like telling you it'd be one of those exactly. All right, 6d. How many can you have in a d? 5. How many can you have in a d? Does the energy level matter for this? No. Okay, F. 7. We'll come back to G. How many for S? 1. Okay. G. N is equal to 5. This one actually requires a considerable. Actually, this one's pretty easy. Well, all right. You know what? We'll break it down. So N is equal to 5. Now, what this requires you to do is figure out all the sublevels. So this is really, truly more of a question from before. You don't even really need to use the quantum numbers to figure this out. If N is equal to 5, what are our possible sublevels in that 5th energy level? All of them? You're correct. All of them. All right, so if N is equal to 5, well, that means we can have an S, a P, a D, and an F, right? Because the S starts at 1, D starts at 3, F starts at 4, and P starts at 1. So you can have all of them. So you can have an S, a P, a D, and an F here. So this is just simply how many orbitals do you have in S? How many in 3? Or P, 3, plus 5, plus 7. What does that come out to be?
16.
Does it? Okay. 16. Questions? Is this helping?
Yeah.
Okay.
Good. All right, flip it over. There's more on the back. You didn't know there was a back?
No.
Now you know. And knowing is half the battle. All right, this one requires you to think a little bit, all right? This requires a little bit of thinking. So, the quantum number, this is saying basically like, what's what here? So the quantum number N describes simply the energy of an atomic, energy level, energy, anything that has to do with energy is fine. Okay, does that make sense? It's saying energy level. The shape of an atomic orbital. This is one you got to think about. Remember, we said that the S, the P, the D, and the F all have different shapes. The only two you have to remember being the S is a sphere and the P is a dumbbell shape. Those are the only two you have to remember, but F and D also have other shapes. Which quantum number tells us which one of these it is? Someone said it.
L.
L. Yes. Because if L's 1, it's a P. If L's 0, it's an S. It tells you the shape. All right? This one we'll come back to because I do not have an electromagnetic spectrum in front of me. If you didn't get that one, don't worry about it. I kind of forgot that was on there. But if you did use your electromagnetic spectrum from before, we'll go into that. This would require you to do a calculation where you figure out the wavelength of the orange light and the yellow light, kind of like we did before on the quiz and stuff, and compare the two. We'll go on to that later. The maximum number of orbitals that may be associated with a set of quantum numbers n equals 4 and L equals 3 is... Anybody got that one?
I put 7.
You put 7. Why'd you put 7?
I did it yesterday.
Anybody else put 7? We're on this one now. Well, the answer is 7.
Oh, because it's 4 out.
So, n is equal to 4, L is equal to 3. You translate that, you write 4. If L is equal to 3, what sublevel is that equal to? Well, remember, this is 0, 1, 2, 3, so it's 4F. How many dashes, how many orbitals do you have in an F sublevel? 7. This also makes sense because what are the possible values for M here? -3 to +3. How many does that equal? 7. 7 dashes, 7 possible values.
And so M is the number of orbitals?
Mm-hmm. M is the number of orbitals. The maximum number of orbitals that may be associated with a quantum number set. Okay. So, specifically, this is getting pretty specific here for E. How many orbitals does that represent? 1, and that's it, because it gives you one value for M. It's telling you specifically it's the -2 orbital, which is the first, we'll say the first D orbital. All right? So, 1. So, G, when n is equal to 5, the possible values of L are 0, 1, 2, 3, and 4. All right, maximum number of orbitals that can be assigned to the n equals 4 shell is all of them again, because remember, 4 has S, P, D, and F. So what did we say it was on the last page? 16. All right. I will talk about number 8